again, this is now what's called a unit column, okay? So we're finished with one cycle of the simplex method process. What we're gonna do now is the same thing we did when we started. After we had our table created, the first move was to determine the most negative entry. Again, if you have a negative entry, you're not finished yet. We do have a negative entry. It's our only negative entry. So this is going to be our pivot column, all right? It's only negative entry, so it's gotta be our most negative. This is our pivot column. Remember what we do after that? We have to figure out the smallest ratio between row 1 and row 2. So this first ratio, you gotta use the pivot column for the value in the denominator. So 6 divided by 1/2. 6 divided by 1/2 is the same as 6 times 2, so this ratio is 12 for row number 1. Row number 2 would be the ratio of 12 to 2. 12 divided by 2, that's 6. So because the smaller ratio is now, with respect to row 2, this is your pivot row, which means that this number, okay, is going to be your pivot entry. We have to make this become a 1, all right? So let's see how to do that. Okay, so this is just like the one we did previously with respect to row 1. It's a 2 again. So we got to make this a 1. So all you gotta do is write down the reciprocal of 2, which is 1/2, and multiply it by the row where it's located. So that's row 2. So the row operation is 1/2 row 2. So what will we get here for our new row 2? Well, just multiply every single one of these entries by 1/2. And that would give you a 1, a 0, a negative 1/2, a positive 1/2, a 0, and then 1/2 times 12 is 6. Everything else stays exactly the same, all right? So I'll go ahead and fill out the rest of this. All right. So we've established our new pivot entry. At this time, we need to do what? That's right. We need to zero out every other entry in the first column, okay, to create what's called a unit column. So to do that, what row operations will we be performing? Well, row 1 needs to change, so write down row 1. And how do we make this a 0? All you have to do is write down the opposite of that number, and then do what? Multiply it by the row in which we just created a pivot entry, which is row number 2. All right? We also need to change row 3. We need to make this a 0 as well. So to make this a 0, we write down the opposite of that number, which is +4, times again the row in which we just created a pivot entry. And then you're going to rewrite your simplex table just like this. And so row 2 is not going to change, right? So I'll go ahead and put those entries in there. That would be 6, okay? All right, so what's going to happen here? Well, let's see. Row 1 minus 1/2 row 2. Start with column number 1. There's 1, or excuse me, there's 1/2, row 1. 1/2 minus 1/2 times 1. What's 1/2 minus 1/2? It's 0. That's the whole point of doing what we're doing here. All right, and you continue to perform these row operations as you go from left to right, okay? So what will we get here? We get a 1, then we get a what? We get 3/4, I believe. And then we get a negative 1/4. Then we get 0. And then we get what? I'll go ahead and walk you through this one. We get a 6. 6 minus 1/2 times 6. So 6 minus 3, that's going to be 3. Again, if you want to use your calculator, perform these row operations, you're certainly welcome to do so. The point I'm trying to make here is we've already discussed row operations, so this should be review. I am using them, obviously. I'm reviewing them to an extent. But the biggest concept here I'm trying to convey to you, the biggest thing is the simplex method, trying to get you to understand this process. So let's perform this final row operation. -4 plus 4 times the entry in row 2, column number 1. So -4 plus 4 times 1. -4 plus 4, that's 0. 0 plus 0, 0. 6, right? Moving on to the third column, row 3. 6 plus what? 4 times negative 1/2. That's 6 minus 2, right? Which is the same as 4. Here we get 0 plus 4 times 1/2. 0 plus 2, that's 2. Here we get 1 plus 4 times 0. That is what? 1. Very good. And finally, we get what? Final column, we get row 3. So 72 plus 4 times 6. 4 times 6 is 24. So 72 plus 24 is 96, I believe. All right, so we've created our unit column. We no longer have any negative entries, okay? Or I should state better that all the entries are non-negative, all right? So we know we have obtained an optimal solution, all right? Here's how you'd write out the solution. You look at the first column, X. If it is a unit column, which means you have a 1 and zeros everywhere else, this is going to be part of your solution. So X is going to be equal to what? Find 1 and then go all the way over to the right to see what the constant is that corresponds to X equaling 1. Notice this is in row number 2. So a 1X is the same as or equal to 6. Okay, Y is going to be equal to what? Well, in this case, it is a unit column, so it will be equal to one of these constants. The 1 is located in row 1, so 1Y is equal to 3. All right? Go column by column here. Stay with me. Notice the column labeled U. This is our slack variable column. This is a non-unit column. It's a garbage column. Because that's true, you write down U equals 0. Same for the V column. It's another garbage column because it's not a unit column. So you write down V equals 0. If this were an application type problem, if you were using raw materials of some sort to produce something and there were leftover raw materials, the leftover raw materials would come up in these slack variable columns. That's not happening here, obviously, because we have no context involved, but I'm just stating a fact. If there were any leftover raw materials, they would show up in these columns. And therefore, if there were any raw materials left over, one of these or both of these would have to be unit columns. Okay? So, anywho, finally, what is the maximization of this thing? Well, it's going to be based on P, so 1P, and then whatever you get here in the constant column, row 3. So 1P equals 96, therefore P equals 96. All right? So all of this represents your solution to this particular linear programming problem. I know it's a lot, but if you practice a few of these, they will not be that difficult. They really won't, but you got to put the time and effort into it to get the process down. Once you get the process down, they will go a little bit faster, and I hope you'll be all set. Okay, that completes example number 1.